Hello students, here is the seventh question of the exercise 1.1, and in this question he has given that show that the relation R which is defined on the set A. So A consists of books in a library of a college, and the relation R is given by so X and Y books have the same number of pages is an equivalence relation. So in this question we need to show that the given relation R on the set A is an equivalence relation, and the relation between the first and second books is both the books have the same number of pages. There reflexive relation means all the elements belongs to the defined set must be related to itself, and symmetric relation means if the pair AB is in R, then there must exist the pair BA also in the relation R. And transitive means if the pair AB and BC in the relation R, then there must exist the pair AC in that relation R. So this is nothing but what? Reflexive relation, and this is a definition of symmetric relation, and this one is a definition of transitive relation. The relation which is reflexive, symmetric and transitive, that relation is called as an equivalence relation. So here we need to prove that this relation is an equivalence relation. So for that, first we need to prove the given relation is an reflexive relation. So for that, consider the elements in the set A. For all A belongs to the set A. So A is nothing but one of the book because it is taken from the set A. And we know that if you compare this A with itself, so A and A have the same number of pages. So A book, when he compared with itself, both the books having same number of pages. So since A and A have same number of pages, same number of pages, it means the pair A belongs to the relation R. So which implies the relation R is a reflexive relation. Is a reflexive relation. And now we need to prove that this is one of the symmetric relation. And for that, consider two books. For example, A and B are the books which are taken from the defined set A. So let consider one of the pair AB belongs to the relation R. Now we need to check whether it's reverse order BA R ಒಳಗೆ ಅದನ್ನೆಲ್ಲ check ಮಾಡಬೇಕು. If it is exist, then it is symmetric. If it doesn't exist, it is not a symmetric. So here we considered the pair AB in R. According to the relation between first and second elements, A and B have the same number of pages. A and B have same number of pages, same number of pages. ಈ ರೀತಿ ಹೇಳಿದ್ರು ಒಂದೇ ಉಲ್ಟಾ ನಾನು B and A, which implies the books B and A also have the same number of pages, have same number of pages. So it means the pair BA also belongs to the relation R. So which implies R is a symmetric relation. Which implies R is a symmetric relation. I hope all of you understanding. Now for the transitive relation. Now for the transitive relation, consider three books. For all A, B and C belongs to the defined set A. For all A, B and C belongs to the defined set A. Now we need to consider whether the pair AB, BC and AC are in or not. So for that, first I am going to consider the first two pairs in the relation R. So let the pair AB belongs to R and BC belongs to R. ನಾನೇನು ಕನ್ಸಿಡರ್ ಮಾಡಿದೆ ನೋಡ್ರಿ ಇಲ್ರಿ. First I consider two pairs AB and BC in the relation R, and we need to check whether the pair AC is in R or not. If exist, it is transitive. If it not exist, it is not a transitive relation. See here we considered what? AB belongs to R. It means the books A and B have have same number of pages, have same number of pages, and also BC belongs to R means B and C have same number of pages, have same number of pages. See here, for example, A is one of the book, B is another book, and C is another book. Suppose the books A consists 10 pages and books B consists of 10 pages, because we consider A and B have the same number of pages. And also we considered B and C have the same number of pages. It means C also has 10 pages. So definitely A and C also have the same number of pages. So if A and B have the same number of pages and B and C have the same number of pages, then definitely the books A and C also have same number of pages. Same number of pages. I hope all of you understanding, which implies the pair AC belongs to relation R. So hence this relation R is a transitive relation. Is a transitive relation. Now observe here, since this relation R is a reflexive relation and symmetric relation as well as a transitive relation, it means the given relation R is an equivalence relation. R is an equivalence relation. I hope all of you understood this question. Now let's start the next question. And the next question is, so here in this question he has given that one of the relation R which is defined on the set A consisting the elements 1, 2, 3, 4, 5 given by the relation between first and second elements is modulus of difference between them is an even number. We need to prove that it is an equivalence relation. So here also we need to prove that the given relation is an equivalence relation. See here, this relation defined on the set A consisting totally 5 elements 1, 2, 3, 4, 5. Now see here, the relation between first and second elements is modulus of the first minus second element is equals to even number. So for the reflexivity, mentally calculate ಮಾಡ್ರಿ. Suppose I consider one of the element. So we need to check whether this element related to itself or not. It means modulus of A minus A should be one of the even number ಇರಬೇಕು. So the value of A minus A is 0 and modulus of 0 is 0. So which implies 0 is one of the even number. Definitely 0 is one of the even number. So therefore this relation is a reflexive relation. So for the reflexive relation, for all elements belongs to the set A, we know that modulus of A minus A is equals to modulus of 0 which is equals to 0, and 0 is an even number. 0 is an even number. Since 0 is an even number, which implies the pair AA belongs to the relation R. So if AA belongs to relation R, R is a reflexive relation, or R is a reflexive relation. I hope all of you understand it. Now for the symmetric relation, consider two numbers for all A, B belongs to the defined set A. See here, for this we need to consider first one pair. Let the pair AB belongs to the relation R. Now we need to check whether BA is in R or not. See here. So if AB is in R, definitely modulus of A minus B is an even number. Is an even number. See here, if modulus of 2 minus 4 is equals to 2, definitely its reverse modulus of 4 minus 2 is also one of the even number. Or modulus of 4 minus 8 is equals to 4 which is even number. Its reverse modulus of 8 minus 4 is also equal to 4. So 4 minus 8 modulus 200 plus 4 which is even. 8 minus 4 modulus 200 plus 4 it is even. So it means if modulus of A minus B is an even number, definitely modulus of B minus A is also an even number. Which implies the pair BA belongs to the relation R. So AB belongs to R as well as BA belongs to R, which implies the relation R is one of the symmetric relation. So which implies R is a symmetric relation. Now for the transitive relation, consider three elements for all A, B, C belongs to the defined set A. So let us consider two pairs. Let the pair AB belongs to relation R and BC belongs to relation R. Now see here, if the pair AB belongs to R, definitely modulus of A minus B is an even number. Is an even number. And BC belongs to R means modulus of B minus C is also an even number. Is also an even number. Now see here, if I consider 2, 4 and 6, modulus of 2 minus 4 which is equals to 2, even number, and then modulus of 4 minus 6 which is also equals to 2, which is an even number. Now for first and third, so modulus of 2 minus 6 which is equals to 4 is also one of the even number. It means if modulus of A minus B is even number, modulus of B minus C even number, then definitely modulus of A minus C is also one of the even number. Hope all of understanding. Or you may consider, in other words, ಇದನ್ನು ಯಾವ ರೀತಿ ಬರಿಬಹುದು ನೋಡ್ರಿ, consider A minus C is equals to, ಇದನ್ನು ಈ ರೀತಿ ಬರಿಬಹುದು ನೋಡ್ರಿ, A minus B plus B minus C. A minus C add and subtract by B madini. So minus B plus B get cancelled, again it is equal to A minus C. And observe here, A minus B is an even number. So this is one of the even number. And B minus C is also one of the even number. So addition of two even numbers, you may consider any two even numbers, 2 plus 4, 6, 8 plus 10, 18, 9, sorry, 10 plus 4, 14, 14 plus 2, 16. See here, 2 plus 4, both are even, their addition is even. 8 and 10, both are even, their addition is even. 10 and 4, both are even, their addition is even. 14 and 2, both are even, their addition is also even. So addition of two even numbers is again one of the even number. It means A minus C is also one of the even number. A minus C is also an even number. So if A minus C is an even number, definitely the pair A minus C belongs to relation R. Since AB belongs to R, BC belongs to R, as well as AC belongs to R, which implies R is a transitive relation. R is a transitive relation. I hope all of you understand. See here, R is a reflexive relation, R is a symmetric relation, as well as R is a transitive relation, which implies the given relation R is an equivalence relation. Equivalence relation. I hope all of you understood this question. And this question is important for 3 marks, many times asked in your annual examination. Let's start the next question. And the next question is, so in this question he has to define two relations on the set A, which consist the integers from 0 to 12. And the first relation is, the relation between first and second numbers is modulus of A minus B is multiple of 4. And in the second relation, he has given that first number is equals to second number. And we need to prove that these two relations are equivalence relation. So let's start the first one here. Here the first relation he has given here, R is equals to AB, where the relation between A and B is modulus of A minus B is multiple of 4. Is multiple of 4. Now see here, so for the reflexive relation, for all A belongs to the defined set A, we know that modulus of A minus A is equals to 0. And 0 is a multiple of every number. So hence 0 is multiple of 4. 0 is multiple of 4, which implies the pair AA belongs to the relation R. So hence R is a reflexive relation. R is a reflexive relation. Now for the symmetric relation, consider two numbers, let for all AB belongs to the defined set A, consider a pair, let the pair AB belongs to R. So when AB belongs to R, definitely modulus of A minus B is multiple of 4. Is multiple of 4. Now we need to check whether BA belongs to R or not. So observe here, if modulus of 8 minus 4 is equals to modulus of 4, which is equals to 4. So 4 can be done as 4 into 1. So modulus of 8 minus 4 is a multiple of 4. Consider it reverse order, modulus of 4 minus 8. which is equals to modulus of minus 4, which is equals to 4. So 4 can be written as 4 into 1. So then modulus of 4 minus 8 is also multiple of 4. If modulus of a minus b is multiple of 4, then modulus of b minus a is also multiple of 4. So which implies what? Modulus of b minus a is also multiple of 4. Is also multiple of 4. So it means, which implies the pair BA belongs to relation R, which implies which implies the pair BA also belongs to relation R. So hence R is a R is a symmetric relation. Hence R is a symmetric relation. I hope all of you understood. Now for the transitive relation, consider three numbers. For all A, B, C belongs to the defined set. For all A, B, C belongs to the defined set A. So consider two pairs. Let the pair AB belongs to R and the pair BC belongs to the relation R. So if AB belongs to relation R, definitely modulus of A minus B is multiple of 4. Is multiple of 4. And BC belongs to R means modulus of B minus C is also multiple of 4. Is also multiple of 4. I hope all of you understanding. Now, for the AC pair, we need to check whether modulus of A minus C is multiple of 4 or not. So, observe here. See here, if modulus of 8 minus 12 is equals to modulus of minus 4, which is equals to plus 4, and 4 can be written as 4 into 1. It means modulus of 8 minus 12 is multiple of 4. And then modulus of 12 minus 16 is equals to modulus of minus 4, which is equals to plus 4. And again 4 can be written as 4 into 1. It means modulus of 12 minus 16 is also multiple of 4. So modulus of A minus B is multiple of 4. Modulus of B minus C is also multiple of 4. Now we need to check modulus of A minus C, that is modulus of 8 minus 16 is equals to modulus of minus 8, which is equals to plus 8, and 8 can be done as 4 into 2. It means modulus of 8 minus 16 is also multiple of 4. When modulus of A minus B is multiple of 4 and modulus of B minus C is multiple 4, then definitely modulus of A minus C is also multiple of 4. That's why the pair AC belongs to this relation R. That's why the pair AC belongs to the relation R. Or you may consider in other words, see here. So ನೋಡ್ರಿ ಇನ್ನೊಂದು ರೀತಿ ಯಾವ ರೀತಿ ಮಾಡಬಹುದು ಇದನ್ನ, consider A minus C can be written as A minus B plus B minus C. So as you know that this A minus B is multiple of 4 and B minus C is also multiple of 4. So as you know that 8 and 12 are the multiple of 4 and 8 plus 12 is equals to 20. So 20 is also multiple of 4. Or you may consider 8 plus 8. 8 plus 8. 8 is multiple of 4. 8 is a multiple of 4. 8 plus 8 is equals to 16. 16 is also multiple of 4. Or you may consider 20 plus 4, which is equals to 24. 20 is multiple of 4. 4 is multiple of 4. So 24 is also multiple of 4. So addition of two multiples of 4 numbers is again a multiple of 4. So A minus B is multiple of 4. B minus C is multiple of 4. Which implies A minus C is also multiple of 4. Or you may say that modulus of A minus C is also multiple of 4. Is also multiple of 4. So which implies the pair AC belongs to relation R. Since AB belongs to R, BC belongs to R as well as AC belongs to R, which implies R is a transitive relation. R is a transitive relation. Since R is reflexive, symmetric and transitive, which implies the given relation R is an equivalence relation. R is an equivalence relation. I hope all of you understood. This question is important for 3 mark, many times asked in your annual examination. Now in this question only he has given that the second question, and for the second one, see here. Here the second relation on the set A is R is equals to AB, where A is equals to B. So first and second elements are equals to each other, and we need to prove that this relation is an equivalence relation. So for the reflexivity relation, let us consider the element for all A belongs to the defined set A. And we know that every element equals to each other. A equal to A, B equal to B, C equal to C. It means the pair AA belongs to the relation R. So which implies this relation R is reflexive relation. R is reflexive relation. I hope all of you understand it. Now the for symmetric relation, for the symmetric relation, consider two numbers A and B belongs to the defined set A, and consider a pair. Let the pair AB belongs to relation R. So when AB belongs to R, definitely the first element is equals to second element. And this can also be expressed as B is equals to A. If B is equals to A, the pair BA belongs to the relation R. So if AB belongs to R, definitely BA belongs to R. It means this relation R is symmetric relation, is symmetric relation. Hope all of you understood. Now for the third one, for all A, B, C belongs to the defined set A. Consider two pairs. Let the pair AB belongs to R and BC belongs to R. So since AB belongs to R, definitely A is equals to B. And BC belongs to R means B is equals to C. So observe here, A is equals to B and B is equals to C. It means A is equals to C. When A is equals to C, the pair AC belongs to relation R. So AB belongs to R, BC belongs to R, as well as AC belongs to R, which implies this relation R is transitive relation. R is transitive relation. Since R is reflexive relation, symmetric relation, and transitive relation, hence this relation R is an equivalence relation. Equivalence relation. I hope all of you understood this question.